Good morning, ladies and gentlemen, and welcome to Fujitsu Executive Session. My name is Goro Watanabe. I'm from Fujitsu R&D Center, North America. We're based in Sunnyvale, California, just 1 hour ride south of here. And Fujitsu, if you're not familiar, actually we are world number 3 largest ICT corporation in revenue. Our products range from tablet computers or cell phones to supercomputers, which I'm going to talk about today. And we even have submarine cables, which actually we are famous for. So we do pretty much everything ICT, and well, actually we're probably more famous in Asia or Europe. We provide services and products worldwide. Today I'm going to talk about 2 topics. One is the disaster that struck Japan in March, and the other topic will be the supercomputer, the world's fastest supercomputer we recently announced. So before we start the session, I'd like to talk a little bit about the special gift for you. By the way, do you know how many sessions are going on at the same time as this one? Any idea how many sessions? Starting at 11:45. 20, 40, 50. Not even close. There are 94 other sessions going on. It's crazy. OW is getting bigger and bigger every year. It's crazy. So including this one, it's 95 sessions ongoing. So it means I'm glad you are here, and it's almost a miracle you are here. You picked one out of 95. So you're so blessed. You're a distinguished audience. That's why I'm going to show some appreciation. I wish I could give every one of you this one, but no, I'm sorry. But not just one, but not just 2, 3 Fujitsu tablet computers. It's cool, actually. It has fingerprint recognition device built in there, and separate USB, HDMI, so it's easier to use than iPad. It's the part you love. Actually, I have both, but in some cases I use. Okay, I'd like to start the session with this beautiful video.
Japan, a country where nature changes with the seasons. Moving from season to season with you.
You might remember this beautiful video because we showed it last year at OW. Everybody liked it, I liked it too. So everybody, Japanese or non-Japanese, came to know the beauty of Japan's nature. They love it. Even the bloodiest samurai warriors 1,000 years ago in Japan, they loved the beautiful nature, and then they wrote poems. So it's not too much to say that Japan's beautiful, unique nature has made Japan's unique culture, but a unique language, unique people's mindset, and technologies, arts, or even video games or animations. But this year, I have to show you another video. Another face of nature. It's March 11th this year in northeastern Japan. It was one of the worst disasters humans have ever experienced, not just Japanese humans have. And what you're looking at is just part of disaster. Same thing happened on the coast of like hundreds of miles long. So you can guess how serious it was. 30,000 lives were claimed, and millions lost their family members, friends, their house, jobs, everything, their town. It's gone. So it's a real natural disaster. Those pictures were taken by Fujitsu employees in the area, or the Fujitsu employees went there to support people. Or some of them are taken by my personal friend. Like let's see the last picture, jump up the last one. So my friend found his car, vehicle on the platform of the station. The same thing happened everywhere in 100 miles long coast. Japan has everything beautiful, from frozen ocean to the tropical island, and every natural scenes, beautiful scenes. But that also means Japan is home to natural disasters. Japan is located at the crossing of 4 different plates, according to plate tectonics, which is earth science. So naturally, we are destined to have lots of earthquakes, tsunamis, or active volcanoes, volcanic eruptions. We are also, Japan is also located at a place where the big typhoons are coming, are supposed to run. So naturally, we have lots of deadly typhoons every year. Well, actually, last couple of months, two deadly typhoons visited Japan and killed 100 people. So that happens every year. And we even have the world record snow area on the north. Snow can kill people. So we have earthquakes, tsunamis, volcanic eruptions, landslides, avalanches, so pretty much everything in this small country. So it's a kind of department store of natural disasters. So like the beautiful nature has made Japan's unique culture, technologies, these natural disasters made the Japanese as they are, and the Japanese technologies as they are. I'd like to show you some examples of Fujitsu's or Japan's technologies against disasters. The first example is buildings, actually. Well, on March 11th, they felt a strong shaking, even in Tokyo. So many people couldn't even stand it. That's how they described it, like that. And the desks all moved all over the Tokyo. But none of millions of buildings fell, because Japan has very strong, strict building standards and advanced construction technologies against natural disasters. So a good example is our new data center near Tokyo. I don't go into details, but this data center has lots of new technologies against disasters. Very few data centers in the world have this level of anti-disaster features. The next example will be interesting.
緊急地震速報、震度5弱、強い揺れに備えてください。
Sorry to surprise you, but it's an earthquake warning system service which Fujitsu is providing. Let me explain a little bit. It says in 30 seconds, 29 seconds, you are going to feel the shaking of 5 is the strength, and the magnitude 8.4. The epicenter is in the ocean of that area. So if you subscribe the service, your PC monitor will show the screen, or your cell phone will receive a call from the system, and you will know that you have 30 seconds, 40 seconds before you feel the shaking. Well, actually, Japan is such a natural disaster country, and we have a lot of sensors, earthquake sensors all over the nation, or even in the oceans. So It's hard to tell when and where it will happen, but once it happens, we can tell exactly how much time you have left before you feel the deadly shaking. If you have 30 seconds, 40 seconds, you can do something, right? You can get under the desk, or you can get out of the dangerous buildings. So it would help a lot of lives. Next example is everybody's favorite. It's bullet train. It's made in Japan original bullet train. It's safe, very safe. Japan started its bullet train service in 1964, very much 50 years ago, or 20 years before any other bullet train systems appeared in the world. TGV started the service in 1981. So it's, I would say it's very original. You see, it's very fast. It's not fast forward. It's actual speed. Right? It's too fast, so digital recording can't catch up. So it's not even straight. You see, the other train is passing. How fast? You see? It's actually 3 seconds for 400-meter long trains to pass each other. It's crazy speed, isn't it? 1, 2, 3, and you pass 400 meters. And one train carries approximately like 1,400 people, almost 1,500. So 3,000 people passes in 3 seconds. Do you know what I mean? Isn't it scary? The scariest idea would be, a train derails, hits other train, or derails and get tailgated or hits other houses around. But it has never happened in Japan. It's not just luck. Because, you see, in 50 years, they carried 8 billion people, 8 billion passengers, which is more than the population of Earth. And there has been not a single passenger casualties. It's kind of amazing, isn't it? Considering Japan is such a country with natural disasters. There's a secret, lots of secret. Where's my Shinkansen? Okay, thank you. It's cool, actually. I love it. I can talk about it 1 hour, but we don't have that time. This bullet train system has a similar system that I explained in an earthquake warning system. So once one of the sensors detects an earthquake happen in the area, within 1 second it contacts the train. It's all automatic, nothing manual. And orders all the trains in the area to stop. And also the trains have very special emergency braking system, which no other trains on the planet have. So it's pretty safe. So I really hope California, Texas, those states planning to introduce Shinkansen, bullet train, would take Japan's technology. When we are talking about 200 miles an hour, safety is fast, right? You don't want to hit each other at 200 miles, no, never. So safety first. So Shinkansen is so Japan. It's a safe, clean, fast, comfortable, everything. So I think it's so Japanese. The last example is again Fujitsu. We have PC manufacturing facility in the damaged area. But we could successfully transfer all the operations, the manufacturing capability to two other sites, one in West Japan and the other in Germany. For those, if you're familiar with factory operations, this is a miracle. It usually takes many months or even a year or two to transfer the capacity of one manufacturing facility to others. But we have been practicing, so it's no matter, it's practice. We're ready for the disaster. We also sent support teams to the damaged area on the very next day. And they helped our customers, and they salvaged the damaged ATMs or other devices, so our customers can get back to business as soon as possible. Oh, here's a shocking video. As if the earthquake and the tsunami were not enough, we had to face a new type of disaster, which of course is the nuclear reactor malfunctioning. What you're looking is the chopper, military helicopter, large one, dropping tons of water to the damaged reactors. It doesn't seem working, but they are not desperate. They did everything they could. To make long story short, some brave people have been working, they're still working there. It's a kind of suicide mission. But they're trying to rebuild the cooling system. Cooling is essential to nuclear fuels. And 4 reactors out of 6 are under control. By under control, I mean put them under 100 degrees C. If we can keep them under 100 degrees C, we can say it's cool, actually, cool and safe. And the government set the goal. We are going to have to put the two other reactors under control by the end of this year. But we have a lot to do cleaning, damage control, and future planning. Cleaning. Did you know that? I didn't know until recently that cleaning means you peel off all the ground, contaminated ground by 5 millimeters, 10 millimeters, and then they detox the soil. So it's enormous work left. So one thing I like to emphasize here is don't panic, be scientific. So many people, especially foreign people, rushed out of Japan, Tokyo, because they are scared of radiation. Of course, it's invisible. You are scared. But this data I got from Consulate General in San Francisco. Consulate General of Japan, so it's reliable. 1 month after the disaster, the radiation level in Tokyo is much lower, actually lower than other major cities in the world. And the latest data says it's 1 month ago, Tokyo is still lower. Well, radiation is kind of natural. It's not organic, but it's natural. And we're exposed to radiation from the space or from the ground, so it depends on where you're standing. New York is typically higher because of the rocky ground, I guess. So if you're worried about radiation, you better move to Tokyo, Japan. Seriously. So let's be scientific, don't panic. If it's scary high, hurry, get up. So I have to conclude this part with some suggestions. To fight natural disasters, to prepare. It's very important. I'm not just talking about Japan, okay? There's no such place as 100% safe on this planet. So I'm talking about you. We are smiling and laughing today, but we don't know what happened tomorrow. So let's prepare. Prepare means learn from the past, learn from who knows it. So Japan knows it best. And let's arm with science and technologies, because those natural disasters are a result of science, some sort of science, okay? So let's fight natural disasters with science. This is our weapon. And Japan knows best about technologies. I sound like selling Japanese technologies. That's true. Today I'm a salesman with Japanese technologies. Act big, don't panic. And be human, which I think is most important. I think you have a chance to read some articles on what happened in Japan. They were really calm, and they didn't panic even after the disaster in the camp. They are very organized, and they formed a line for the supply, things like that. So no looting, no riots, no violence, no nothing like that. So if you like that, it helps you actually. So they are helping themselves by staying calm, staying human. And they help a lot. They help support people. If they are like crazy, it's hard for the support team to help them. So this is actually the last slide of the first part of the presentation. So please remember that human is most important. I will be talking a lot about science and technology, but human-centric, which is a keyword, will appear again. Okay, shifting gear to something fun, something encouraging. We announced world's fastest supercomputer in June this year. So I told you that Japan's technology is very good. Technology is not just technology, it's nature, food, gardening, comics. So everything in Japan is cool, nice, beautiful, except for politics. Okay, let's forget it. I don't want to get in trouble. So in this session, I will have a lot of questions. I will ask a lot of questions. So please think with me. Don't worry, I'm not going to point. I'd like to start with a very basic question. What is a supercomputer? Any idea? Any idea? Very fast, okay. Very expensive, okay. You can get one at Fry's. They don't even take your order. So come to me when you want one. Let's focus on how fast, very fast part of it. So, you know, there were supercomputers 40 years ago, 50 years ago, but decades ago, supercomputers are still supercomputers, but this gentleman has some tablet, it's iPad. Buy one. You can get this tablet at Fry's. The gentleman here has an iPad, but that should be faster than the supercomputers 4 decades ago, 5 decades ago. But is the iPad supercomputer? Not really. So the new fast is very much different from old fast. So let's see how fast it is. So K computer is named after Japanese letter, character K, which means 10 peta. 10 peta means 16th power of 10, means 16 zeros. It's a huge number, enormous. So K computer can perform 10 peta floating operations in 1 second. Hard to think about it, I know. So I like to, well, before going to the next slide. This gentleman, one of our engineers, is wearing the same t-shirt. I think you received it, okay? So it's actually a very cool letter. I just wanted to mention it. This is K, but we can also pronounce it Kyo. So Tokyo, Kyo, same character. So this letter means large, fashionable city. So it's very cool. Take it. Beijing, same, different pronunciation, but Beijing uses same letter. So it's a big, fashionable city. Well, anyways, I like to compare K computer with the human. It doesn't make much sense, I know, but let's just compare. So K computer 10 petaflops versus I will give human, each one of you 100 seconds to calculate one floating point operation, which is, to be precise, it's double precision, means 4 by 4 by 8 byte by 8 byte calculation, addition, multiplication, something like that, division. So ordinary people can't do with a pen and a paper in 100 seconds. No, I don't want to do that. I don't even want to try it. It's like 64-bit by 64-bit operation. It's good for computers, but we can. If we still have to try it, then what K computer can do in 1 second is we have to spend 30 billion years. Do you want to do that? But it's only when you work from morning till night, 24 by 7. Every 100 seconds, you calculate using pen and paper, sorry. If you are going to take weekends off and 8 hours a day, it's going to take 130 billion years, which is 10 times the age of the universe. So do you want to calculate from the Big Bang to the 10 times more than the universe, age of the universe? Don't do that. Don't even try that. It's a waste. A supercomputer can do it for you in 1 second. That's how fast. I know it's unfair to compare human with K computer. Let's compare this guy with the other supercomputers. K-computer was officially 8.2 petaflops in June and will soon reach the designed top speed 10 petaflops. So it's basically 4 times faster than number 2 supercomputer. Or as roughly the total of all the historical supercomputer. The K-computer is as fast as that total. So it's a breakthrough fast. How was it possible? I picked 3 differences, how supercomputer and other computers are different. The first one is a processor, which is a Spark 64-8FX. It is Fujitsu's Spark processor. I think many of you are using Fujitsu servers, okay? How many people are using Fujitsu servers? Thank you. Many people are too shy. If you are using Fujitsu Prime Power Spark Enterprise server, you are likely to have Spark 64-7 processor. I know you love it, so you don't have to say it. But this one has extended features like floating operations. This one processor is probably 10 times faster than Intel processors in terms of floating operations. And it's a water cooled, which is really cool. Actually, we have a picture here. This is a water pipe. And lots of new technologies in water cooling. This is very cool, actually. The real box is in a Fujitsu booth, so please visit the Fujitsu booth and see how it looks like. So lots of new technology. Interestingly, this is a water pipe. You can easily plug it off without any door, without any lead. So this is a system board. You can replace the system board without any lead, and you can just attach it to the new system board, and the water is going on just fine. It's a great technology. Actually, I requested a real box here, but they said no nicely, because it's a 1-ton box with 2,000 pounds. Pretty heavy. Well, they're worried about the stage too. You know. But you can see the real one in this book. Okay, next slide. So I need, again, 1 hour to explain everything, but I just picked one thing I like to explain here is robustness, toughness of this processor. This is a chip layer. We have 8 cores on one chip, and then the green, yellow bar says this chip detects hardware error and corrects it itself. So it's very intelligent. Some memories do, but not many processors do it because it's very difficult. So while other servers are down, your server is up. It's not what I said, our customers say. They keep saying the same thing. We keep hearing. So please try. The next difference is interconnect. Interconnect is a feature to link 2 nodes. In this case, processors, 2 processors. So your PCs don't have any interconnects because you have only 1 processor. But when you have lots of processors, they have to communicate each other, like brain cells communicate each other. We need very fast connection. Mr. Ellison was talking about superclusters interconnect, which is InfiniBand. InfiniBand is very popular for high-end servers as an interconnect. I believe most modern supercomputers have 3D torus interconnect, which is already complicated. But Fujitsu has developed new interconnect, which is 6-dimensional mesh torus fusion. It's too long, so we named it tofu. Sounds healthy, actually. It's pretty healthy. So this is you see a conceptual model. Those black balls inside the plastic ball is 1 node. So it's actually looks like this. Those nodes are on the system board. What is it? Conceptual. So 3D inside 3D. Let's see the video.
Fujitsu's original 6D mesh torus. Fujitsu's original interconnect is a 6-dimensional mesh designed for high-performance computing. Specifically, it features a combined mesh torus topology. Computing nodes are arranged in 3D node groups, which are also connected in a 3D torus. First, let's look at a node group. The system consists of a number of racks. Each rack holds 24 system boards. A system board carries 4 computing nodes. 3 boards, which is 12 computing nodes, form a node group. All nodes in a node group have the same XYZ coordinates. The 12 nodes in a node group are interconnected along the ABC axes. The node group is the unit of job allocation. The 6-dimensional mesh is then formed by connecting node groups along the XYZ axes. Each node in a node group is connected to nodes located at the same position in the neighboring node groups. Now, let's look at an example of the routing algorithm. We want to send a packet from the source node to the destination node. The node group containing the source node and the node group containing the destination node are separated by 3 by 2 by 1 hops along the XYZ axes. First, the packet traverses a path in the source node group along the ABC axes. It then moves to the destination node group along the XYZ axes. When the packet reaches the destination node group, it again traverses the ABC axes in the node group to arrive at the destination node. We've introduced Fujitsu's original 6D mesh torus network and looked at how it works. Featuring high-density packaging and high reliability and availability, this switchless interconnect will enable the system to scale to over 80,000 nodes.
Thank you. So now it's clear. You understand it? Wait. Why are you smiling? You don't get it? Okay. Don't worry. You're not alone. I showed this video to my software engineers and asked them if they understood it, they were quiet. So my point, sorry, is my point is you need a very special connection when you build a supercomputer, high-scale computers, and research technology. And it's well, actually, interconnect is what makes supercomputer a supercomputer. And fast, robust, that is a key point. The last slide on difference is the building. It's not even a part of a computer. When you are planning to buy a supercomputer, I strongly suggest to design and build a state-of-the-art building, state-of-the-art computer in state-of-the-art building. This is how it looks like. This is our customer, Riken. It's me. I visited there. It was too hot, so I don't look happy. So I'm going to explain a little bit about this state-of-the-art building using this one. So it has a secondary generator on the back of the building. It's like 100 yards by 100 yards, very big building. Some solar panels on the top of it. And it opens up. Real building doesn't open up. Even the Japanese wouldn't do that. So the bottom basement is actually cooling. All cooling, 100 years, crazy cooling. And the second, the first floor is all storage devices. A lot of disks. We are still using disks, but flash too expensive for them. And the second floor, all cooling again. And the top floor, red ones, they are the real supercomputer, K-computer, on top of it. Here's an interesting question for you all. This supercomputer is, do you know why they're placed on the top floor? Any idea? No. This supercomputer is fastest on the top floor. But why? It's a question. It's an interesting question, so I leave it unanswered. I'm not going to answer the question. But you can think and you can read the answer. I want to keep you interested. Those computers are fastest on the top floor. Why? That is the question. Let's see some interesting video. This 1-minute video shows 7-8 month work there. So each box is this big, 1 ton. So the top floor has 1,000 tons. Well, actually, I didn't tell you. We have 864 boxes of these on the top floor. That makes 10 petaflops. So besides metal, it's a monster of cable. I have talked about tofu, which is interconnect, which is very, very fast, 1,000 times, million times faster than the internet you're using. So it got to be very thick and a big connector there. And we have 20,000 cables connecting all the nodes and racks. So for those who don't believe anything without a legal document, here it is. And this is the certificate. You can see a copy in a Fujitsu booth. So we are showing number 1. The customer is Riken Advanced Institute for Computational Science. I can never remember that. But we are proud of being number 1, but we are also proud of this certificate too. Green 500 is an organization that encourages supercomputer makers to make the supercomputer green. So we are ranked number 6 in 500, top 500. It's not bad, isn't it? But actually, top 5 other guys are mostly experimental, much smaller computers. So I would say K-computer is a real, practical, most energy efficient supercomputer. At the same time, it's the fastest supercomputer. So it's 824 megaflops per watt is a pretty good number. So probably average or median of 500 is 200 to 250 megaflops per watt. So we beat them by many times. So supercomputer, K-computer is many times faster than regular supercomputers. Okay, question time. Because I shouldn't have much time left for questions and answers, I picked some questions that you might ask. The first question would be, why Spark? Why didn't you use Intel or anything like that? Why Spark? How many people would ask, why Spark? Not many. So you don't raise hands, so you should know the answer. I need you to answer here, but kidding. Because I would ask the same questions if I'm on the other side. My answer would be easy. So it's done. I'm kidding. Let's go into a little details. Our Spark, Fujitsu Spark. By the way, Mister, do you know who owns the copyright of x86 processor architecture? My clue is, who owns, who licenses Intel x86 processor architecture? Right, Intel, yes. How about Power? IBM, okay. Who owns Power processor architecture and interface? Who can license? IBM, yes. smart audience. I'm happy. But how about Spark? Do you know who owns Spark architecture? Sun? No. You know that, okay. Not even Oracle, of course, no. Fujitsu? No. Spark architecture is owned and licensed by Spark International, which is an organization founded in 1989, I guess. So it's more than 20 years ago. So Sun, so currently Oracle, Fujitsu, many other members in Spark International. So it's quite public. The most public, probably only public processor architecture, which is commercially available, I think. So if you put your $1 billion or $2 billion, you can build your own Spark processor. Nobody claims. You pay a small amount of member fee to Spark International, it's okay. So we like the idea. It's open, and Oracle makes it, we make it. And also, there's a design flexibility, which means we can do a lot. As long as we keep the compatibility of Spark International, as long as we conform to the architecture definition, we can add a lot of floating point operation features or something like that. We can't do with Intel or any other processors. Intel is owned by Intel. But Spark is owned by Spark International. We can add anything we like, as long as we are compatible. I told you about robustness and green and business critical computing. Well, actually, we are getting some feedback from supercomputing area to your Spark box. It's commercial. So vice versa. So it makes perfect sense to us. We can do commercial supercomputing and feedback to each other. So as I have said, Oracle and Fujitsu are working together in developing the Spark servers and even Spark processor. It makes perfect sense to us because there are broader, different types of customer requirements here and there. Even a supercomputing to the smallest one processor servers. It's hard to cover for one company, but we do different things with Oracle. We can complement each other. This makes perfect sense. By the way, Mr. Ellison, when he met with our CEO, Mr. Yamamoto, weeks ago, he congratulated us for being #1 in the world. Mr. Ellison likes everything #1, of course, not just his yacht. And Mr. Ellison also said, he always says, Fujitsu is a very special partner of Oracle. Well, same here. Because Oracle, actually, and Oracle and Fujitsu have been a special partnership since they were established in the 70s, 80s each. So it's a very special thing for us. Please read. I'm not going to read this. So some analysts think it's good to have competition in the market. Of course, it is. How many people have Intel PCs? Some people don't have one. So I know you Intel lover. Like myself, you don't know how many Intel processors in your home. But what if there are only Intel processors in the industry, in the world? That would be a very boring world, wouldn't it? So as soon as other processor vendors like IBM, Fujitsu, Oracle, AMD, ARM are out of business, Intel will raise the price of Xeon by 20–30%. I would double, triple the price of Xeon if I was CEO of Intel. I can do that, but you can't do anything, right? You want to be happy, but you can't do anything. You still have to buy from me. Thank you. So that's not good value. So if you love Intel, please buy Spark. Please buy our servers. If you love Intel, it's perfect sense. Why supercomputer? Well, similar questions here. when we are talking about smartphones, tablets, why are we still talking about supercomputer? How about cloud computing? Can't cover supercomputing? To answer this question, I'd like to show you some demonstration video. It's a supercomputer applications, maybe 9, 10 applications. They don't, I admit that, they don't look as realistic as latest video games. Do you agree? But they are simulating the real world. You know, computer games are their imagination. Did you know that? It's imagination. I keep telling my son that their imagination, not real. But supercomputers can help humans to see what we can't see usually, because the real world is sometimes too slow, too fast, too micro, so we can't see everything what's happening. The supercomputers can help us to see what's happening in the real world. So they help us to understand the universe. They help us to create something we haven't ever created. So, a couple examples here. In the past, they designed medicines using the real ingredients, changing a little bit the amount of the ingredient, changing a little bit by little bit, tested with animals, back, many years waiting. But these days, because of the chemistry has made a lot of progress, they can tell what's going to happen by, configuring the medicine using a supercomputer. Change a little bit. Supercomputer can do it in a few days. So we can save a lot of time. We can save more patients because we can introduce safer, better medicine to the market earlier, much earlier. We can save a lot of animals. We don't have to test with animals. But same more traditional thing, I think you have a better idea about this. Automotive, crash computing. You can save more times, of course, save more lives, because you can have safer cars in the market much earlier. Same what dummies, I'm not joking, I'm talking about crash testing. Dummies means same number of cars are crashed and broken. They're very expensive. But who do you think is paying for that? You. Customers are paying for the crashed cars and dummies. But with supercomputer, you don't have to pay for that. So you can enjoy cheaper, safer cars much earlier than without supercomputers. Here's an interesting topic. But somehow related to cloud computing versus supercomputing. Let's think about 1 million PCs here. It's about the population of San Francisco. So everybody's opening their notebook or something. And here's a supercomputer. They are roughly the same performance. Interesting, isn't it? In terms of floating operations. If they're in the black box, which would you like? If the performance is the same, maybe you would think same. But to make long story short, I'm making too many long stories short today, but my apology. But I'm running out of time. From engineering point of view, they are totally different things, in different world. My analogy would be one genius versus 1 million average people, like me, not you, like me. So they are good for something different, okay? You put 1 million average people, but they can't come up with a theory of relativity. We need somebody like him to come up with something very special. The same thing. So this was a kind of trick question because which is better? In some cases, this one is better. Actually, in most cases, 1 million pieces is better. If all the people in San Francisco they don't have any computer, they want a computer, I would strongly recommend 1 million PCs instead of just one supercomputer. When you want to chat with friends or Facebook, things like that, you don't need a supercomputer. Don't even try it. So let's talk a little bit about the future of supercomputing. So humans, we are curious animals. Humans are humans because we are curious. And once we know, we learn something, we want to learn more. That's why we have science. Getting better every year. So the supercomputer, because modern science requires lots of calculation power. Because the modern science produces a lot of different theories. To prove it, and prove it, we need computing power. In other words, future of supercomputing and future of humans. As long as we have future supercomputing group, we don't know what form it would be. It can be a biocomputer or quantum computer. We don't know about it. So we need supercomputing. But it has some issues to be considered. We need easier software development for everybody. It doesn't have to be real everybody. Every scientist, if they could write software easily and they have access to the supercomputer, that would be a great world. It's kind of business model. There's same thing between PC and supercomputer. Very same. What do you think it is? It's business. Somebody has to pay for it. PC is cheaper. A lot of buyers. My supercomputer is necessary for the humans, but how to buy? So if we could rent a supercomputer instead of rent a car, that would be a great model for the future of humans. You know, each person doesn't need a supercomputer. It's like a space rocket or the X-ray telescope. Each one of it doesn't want it home, but humans need it. Supercomputing, same story. Some analysts say future of human is very bright with the supercomputing. I totally agree with them. Let me conclude quickly. We never give up, right? That's why we develop science technologies. Supercomputer is a driving force. Let's see, Kobe. Kobe is famous for Kobe beef, of course. We pronounce like Kobe. Kobe. In 1995, they were attacked by a huge earthquake that killed 6,000 people. Another disaster. But let's see what happened. So the Japanese, the humans built a supercomputer, world's fastest breakthrough supercomputer, near the epicenter of that huge earthquake that killed 6,000 people. So this is a message from humans, not just Japan or Japanese, I think. So the natural disasters can get us, but we'll come back stronger. That's a message. So don't forget human-centric. A scientist, Ray Kurzweil, am I right? I'm not quite sure. He's good at predicting the future. He said in 2005 in his book that humans will have 10 petaflops supercomputer in the year 2013. So we beat him by 2 years. And he predicted, well, 10 petaflops is actually, according to his book, is a milestone, big milestone, because with 10 petaflops we can simulate human brain functionality. But next milestone will be 2025, which is we are going to have 1,000 times faster supercomputer in 2005, according to his book, when we will be able to simulate human brain at neuron level. Means each cell, I think. That's 2025. So my own prediction will be 2055. That's when humans will have humanoid robot with human level AI, intelligence. It's not linked to anything independent. Because it's most likely after 30 years your personal computer will have the supercomputer's capability 30 years ago. So 2025 and then 2055, the human neuron system could be simulated by those personal level computer. That's my prediction. We are the center, always. We don't want to terminate a world, right? Human can help human. That's our idea, heart, very important. The US military are everywhere, in every country, Japan too. And they are unpopular, unfortunately, everywhere. But this time they helped the Japanese very much, and the Japanese appreciated their help. But same there, China, India, all the other countries sent help to Japan. We really appreciate it. So I'd like to say thank you to all the world on behalf of Japan and Japanese people. So this ends my presentation. Thank you very much. Here comes last fun part. It's the tablet. You ready? So you look at your ticket. I just have some words about this. Hi, Tom. Hold on a second. I want to say something. Fujitsu actually is the #1 tablet company in the United States last quarter, while they are setting it up. We are very pioneer in this area. Thank you. It goes to him. Wait a minute. What I was going to say. Tom, sorry. What was I going to say? How many people would think, oh, Fujitsu is following Apple? How many people would say, oh, yes, you are another follower? You don't think so? Okay, good. I was talking with one of the Oracle SVPs last week, a couple of weeks ago. He's Andy Mendelsohn. He's a very nice database person. I was talking with Andy. I told Andy, I'm going to speak at OW, so please come by. Is Andy here? Not likely. So I told him that he has a chance to win our tablet. He says, oh, Fujitsu is following Apple. I said, no. We started earlier. Name iPad was registered by Fujitsu. It's our name. Apple started last year, only last year, 2010. I just wanted to say this thing. Everybody said, we are following. No, Apple is following us. They just passed us, probably. So bigger guys can beat smaller guys. That's America. But we reached a settlement. We transferred the name iPad to Apple. They can sell more iPad than we could sell our iPad. So don't forget that. It's trivia. So tell everybody. Everybody you know. I'd like to introduce Tom Donnelly, marketing. Your VP? Oh. So say something funny and then just do.
I came down a little early and I said, Goro, would you like me to say anything? And he said, just be funny. Have any of you tried to be funny on command? Is it working? So actually I decided I'm going to sing. All right. You didn't come here to see me anyways. You came to see Goro, and that was an absolutely fascinating and fantastic presentation.
Thank you very much.
Thank you. And I think without further ado, because these people have been very nice and very patient, that we should probably find out who has won the three, well, actually only two. Because
I know they are patient until we pick the third winner.
Yeah, so, well, no, there's only two.
That's true?
Yeah,
this is for you?
This one's mine.
I didn't know that. Well, this one is mine.
There's only one then, I'm sorry. All right. I'm going to put my eyes down here. I'll have to pick them up each time we do it.
Okay.
I tell you, Goro, since you did such a great presentation, why don't we'll spin this, and then you can pick the first ticket. And
my honor. You dropped one.
Oh.
Put it in.
It fell in the back. Nobody knows.
Okay.
He did. It fell. There it is. We got it. Oh my goodness. Look at that.
On the front.
The door has a leak.
Oh, like water cooling.
Yeah. Yeah.
We better introduce new technology.
Let's see. All right. Everybody watch. Make sure we don't lose any more tickets, because you know if we lose a ticket, you know it's yours. Yeah.
Yeah, everybody thinks that.
And again, if they don't claim the prize, you and I get them. So
okay.
I think that's pretty good. All right. I'm supposed to use the crank, but this is actually very soothing. How many times am I supposed to turn this?
Petaflops kind of.
Okay. Get down. Okay.
Okay.
All the tickets are in there.
The first winner.
The first winner is.
Okay. I don't see it. This one.
Is that one?
Yeah. Really.
Okay. The first winner is this one. Who has this ticket?
Good one.
Have to put my eyes on. Office Depot. That's me. All right. 352.
Slowly.
3.
Now the parts, they already know.
352647. 352647. Come on down. Oh my goodness. All right, while he's coming down, actually I want him to pick the next ticket, so hurry up. Everybody's mad at you now. He's not moving very fast.
Yeah. Somebody's running.
Somebody's running. Oh, no, you didn't win. Look at that. Somebody tried to fake it out. This looks promising.
Okay.
You lost your ticket, yeah. Let's see. Oh no, that's not the right number. I didn't call that number. Okay, I tell you what, why don't you come on around? Come up those stairs there.
Jump up.
I'll jump up, yeah. Okay, and you are? Sorry? Goro asked me to be funny. I just bring from the audience. I don't have to be funny at all.
He beats me.
And you are?
Emre Baronser.
Okay, great. Well, congratulations. This is yours. We'd like you to pick the next number.
You're picking the next winner. Because we don't want to take blame.
Get down here.
No ticket out.
Alrighty. Reach right in there and pick one. Okay. Thank you very much. You can leave now. You can have that too, okay. Okay, are we all ready? 264085. 264085.
No.
No? Let's try one more time. Going once, twice, this is the third time. 264085. Na 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 na. Okay.
Going once, going twice.
Alrighty, then Goro, let's pick another.
Okay.
We've already had a good spin, so.
Okay.
Wow, so now that means we can have 4 winners.
Yeah.
4 winners, but 3 people get
Maybe more than that.
the tablet. I like those odds. Okay, 2, 6, 3, 9, 1, 8. Ha ha! Right up front. There we go. Come on up. Come on down. Oh, take the stairs.
There's some trouble.
Oh, falling out again. Okay.
They all disqualified.
Well, they're just unlucky numbers.
Okay, I'll put them in.
Yeah, these are the
Some
old ones.
typical. They should really get Fujitsu.
Yeah, we should have a Fujitsu drum. If we had a Fujitsu drum attached to the Fujitsu supercomputer, you'd all be home by now.
Yeah.
Well, that's subjective, isn't it? Alrighty. And we have the pleasure of Edgar.
Edgar, yeah.
Congratulations, Edgar. Thank you very much. All right, we'll rotate this one more time and hopefully nothing will follow. Is everybody paying close attention? There's nothing up my sleeve. Okay.
Okay.
Mr. Watanabe, one more time.
So follow me. One bottom ticket.
Only one ticket.
Only one ticket.
Only one ticket.
One
Okay.
last ticket.
And we lock this up and get the suspense as high as I possibly can. 2, 6, 4. 1, 4, 4. Oh, I'm sorry you didn't win, folks. But it hasn't been claimed yet. 2, 6, 4, 1, 4, 4. Ah, there we go. We got one. Come on down.
Thank you very much.
Thank you.
Have a nice rest of OW. Thank you.